Section 8.2 focuses specifically on, I'm going to call them arithmetic sequences. You can call them arithmetic sequences, but essentially there's a common difference, which means something is getting added each time. That's the format of the equation, of the rule. So when they say write a rule, I have this formula that I can follow. A sub n just means the term number. N is the term number. A sub 1 is the first term, and D is the common difference. So you're typing into IXL this week, and they're just going to have you type in this right side of the equation. So when I look at number 1 and they say write the rule, I'm going to recognize I need to know what is the first term and what is the common difference. So A sub 1, the first term is 12. So 12 plus, in parentheses, n minus 1. I'm going to leave the n in the problem, and then D is the common difference. What's getting added each time? So what is getting added each time? The answer is 8. So the rule is 12 plus n minus 1 times 8. So that's all you need to do. You don't need to distribute the 8. Number 2, I'm going to set up the first term as 51, and then plus n minus 1, and then times what's getting added each time. So what is getting added each time is a negative 3. So this is all that I need to write. You could distribute the negative 3 and combine, but you don't have to. So for setting up the rule. And the reason that I actually like this format better is because if they ask you to find A sub 20, that means what is the 20th term in this sequence? Though I guess technically you're just plugging in a 20 for n, so you could do it in any format, but whatever, why do more work than you have to? So I'm plugging in a 20 to find the 20th term. Instead of going, okay, this is the first one and the second one and the third one and fourth one, I find the sixth one, the seventh, all that. So I don't want to have to do that. So I'm going to plug in a 20 for n. So 12 plus 20 minus 1, I'll go ahead and write it, times 8. So 12 plus 19 times 8. Let's see here. 19 times 8 is 152 plus 12 is 164. So if you were to write out the sequence to its 20th term, it would be 164. And then the 20th term of this sequence is 51 plus 19 times a negative 3. So 19 times negative 3 is negative 57, plus 51 is negative 6. So the 20th term is negative 6. So you're just saying what is the first term, what am I adding each time using this rule. So A sub 1 is negative 1 plus the quantity n minus 1 times what am I adding each time. So if it helps you to say negative 1 plus what is equal to negative 1/3. It can give you a format to make sure you plug in the right number. What's getting added each time is 2/3. And if I wanted to find the 20th term, I could. And then number 4, I'm finding the rule. So the first term is 2.3 plus n minus 1. And then what's getting added each time? 2.3 plus what is equal to 1.5, and I can 1.5 minus 2.3. What's getting added each time is a negative 0.8 or just 0.8. So if I wanted to find the 20th term, again, I could. So if they were ask you to write the rule, that's the format that they want. If they ask you to find a certain term number, they can do that. And then the last thing that we're actually going to do this week is summation. So it's kind of a relatively short week, I think, in terms of content. But they want the summation. So what does that mean? That means I want to find all of these terms added together. The first term plus the second term, in this case, all the way up to the 20th term. So instead of finding all of those terms and adding them together, because I know this is an arithmetic sequence, I can use a formula. So I have a formula that says S sub n, which means the summation of n terms, is equal to n times a sub 1, this is actually a fraction, so I'm going to make the parentheses a little bit bigger. A sub 1 plus a sub n all over 2. So what does that mean? You can label this if you want to, or you can just write down the formula. N is the number of terms. A sub 1 is the first term. And a sub n is the 20th term. So instead of having to find all of the terms, because it's arithmetic, it's going to follow this pattern. And I'm not asking us to prove this pattern. You can just do that in your spare time. But I want to find the summation of the first 20 numbers of this sequence. So I can just plug in 1, plug in 2, plug in 3, add all these terms together, but I want to use this formula. So I do need to know the number of terms. If I'm going from 1 to 20, that means there's a total of 20 terms. And then I need to know the first term. So I need to plug in a 1 for I. So 3 times 1 plus 7 is going to give me 3 plus 7 is 10. So the first term is 10. And then I need to know the last term. So in this case, the 20th term. So 3 times 20 plus 7 is 60 plus 7, which is 67. So then I'm going to follow this formula that says the summation is equal to n, which is 20, times 10 plus 67 divided by 2. So I'm going to take 77 divided by 2, I'm going to multiply it by 20 and get 770 for my answer. And if I were to plug in, the first term is 10, the second term is 13, I think it would be, because it's going up by 3 each time, so 16, 19, etc. Instead of having to add all those up, I get to use this formula. And then number 6, if you want to try that one on your own, unpause or pause the video and then unpause, we can get the answer. So the formula n, the number of terms in this case is 12. The first term, when I plug in a 1, I get negative 7 plus 2 is negative 5. And then the last term in this case is 12. So don't just be in the habit of plugging in 20. Plug in the n value. So negative 7 times 12 is negative 84, plus 2 is negative 82. So I'm going to add negative 82, divide by 2. So negative 87 divided by 2 times 12, I get negative 522. And then the last one that I want to do, just because sometimes the shorter the problem, maybe the harder it gets. If I look at this problem and I say, okay, let's do it. There are 20 terms. The first term is, there's nowhere to plug in a 1. That just means the first term of this sequence is 8. There's nowhere to plug in a 1. There's nowhere to plug in a 2. The second term in this sequence is 8. The third term is also 8. So obviously, if it's just a bunch of 8s, I can do, multiplication. I just know I'm going to have 20 of them. Or I can take the first term, which is 8, plus the last term, which is also 8, divided by 2. And I end up getting that I'm taking 20 times 16 divided by 2 is 8, and I get the answer of 1/6.